Hello everybody and welcome back. We're going to finish off the 2011 Friar contest in this video. We're on to question number 4. So let's take a look at it. Alright, question 4. Ian buys a cup of tea every day at Jim Hortons. Obvious Canada reference there, popular coffee chain of, well they have tea here, but coffee chain of Tim Hortons. So, nice little Canada reference there. So he buys a cup of tea for $1.72 with money from his coin jar. He starts the year with 365 $2 200-cent coins and no other coins in the jar. Ian makes payments and the cashier provides change according to the following rules. So we have 6 rules here. Payment is only with money from the coin jar. The amount Ian offers is at least $1.72. The amount Ian offers the cashier is as close as possible to the price of the cup of tea. Okay, so that's the $1.72 up here. So initially, he won't have enough change. He'll have to keep giving out, giving $2 coins. He'll never offer two $2 coins for some reason. Change is given with the fewest number of coins. Okay. So they'll give a 10 cent a dime before they give out 2 nickels. Change is placed back into the coin jar, so the spare change from his tea will go back and it'll give us different coins in the jar rather than just a whole bunch of $2 coins. Possible coins that may be used have the values of 1 cent, 5 cent, 10 cent, 25 cents, and 200 cents. Okay, so for those of you who know the Canadian money system, this is the cent, the nickel, the dime, the quarter, not the 50-cent piece or the loonie, but they'll also be toonies. Okay. So these are the possible coin denominations. Alright, so we take a moment, we absorb the rules, we try and understand them as best we can before we start looking at the question, but it's possible that some of the little tricks of these rules will only reveal themselves once we've actually started doing the questions. Alright, A. How much money will Ian have in the coin jar after 365 days? Okay, he buys a tea every day for $1.72. And he starts the year with 365 $2 coins. So all he's been doing is spending his money on the tea and then putting it back in the jar. So it's really the difference of the total money he has, and then we subtract off how much money in tea he has spent during those 365 days. Okay. So 365, we'll keep everything in cents for a moment. $365 times 200 cents. We can get our calculator out. 365 times 200 equals 73,000 cents. That's how much money he has at the start of the year. So he starts with. So he spends $1.72 on coffee. That's 172 cents. So he spends 172 cents each day. So after 365 days, he has spent 365 times 172 cents. 365 times 172. That's 62,780 cents. So how many cents does he have left over? Well, we just take the difference between these two. 10,220 cents, which is really $102.20. So we'll just underline that answer right there. That's how much money he has left over after 365 days. Okay. And that's all we were asked for in A part. How much money will he have in the coin jar after 365? We have it listed both in cents or the more conventional dollars and cents notation that we're given at the start. All right. So with A done, we're on to B. What is the maximum number of 25-cent coins that Ian could have in the coin jar at any one time? Okay, bit trickier. So he spends his $2 coins at the start because that's all he's got, and then he gets back 28 cents. Right, that's the difference between the cup of tea and the $2 coins that he'll be giving out. Because at the start of the year, he can only be giving $2 coins to the cashier until he builds up enough of the rest of the change to to spend with the other types of coins. So to get 28 cents back, the easiest way would be 1 25-cent piece and 3 1-cent pieces. That's the quickest way to get 28 cents with 4 coins there. So first day he'll get back a quarter. And the next day he'll get back a quarter and so forth. Well, you can't have 8 coins, I don't think. Okay. All right, now why can't he have 8 25-cent coins in the jar? If he were to get an 8 25-cent coin, that would mean that he has 7 coins in the jar already, but if he had 7 coins, he would spend that on the $1.72. Let's rewrite this in a more intuitive way. every day he could spend a 200-cent coin. Now, if he has other change in the jar that would make up $1.72 or something between $1.72 and $2, the rules say he has to spend that. But at worst, he's spending 200 cents in coins on the tea. Some days he might be better, but under no circumstances will he ever spend give the cashier 201 cents or more for his tea. Okay, so that means every day he is getting back at most 28 cents and change. We have 1 25-cent and 3 1-cent. So every day he can gain at most 1 25-cent coin. Okay, now we can conclude that he'll never have 8 25-cent coins in the jar. Okay, and we'll do that as follows. Before I was going to notice this and then explain it, but it makes more sense to write my explanation, my preamble, as a preamble. So if he had 8 coins one day, then at most during that day, he gained a 25-cent coin. Either he handed in another toonie and got 28 cents back in change, or whatever. That day he got one more 25-cent coin. So he went from 7 to 8. But that means the previous day he must have had 7 25 cents, but that's 175 cents. So at most he can have 7 25-cent coins. And that would mean he started the day with 6 of them, he spent a toonie or something else, got another one, and then he got 7 25-cent coins. The next day he has to use those 7 25-cent coins to purchase tea. Okay? But we want the actual maximum. I mean, yes, he could have as many as 7, but maybe something else means that he can only have 6 or something. So we have an upper bound. Can we obtain that upper bound in the reality of the question, in real life? Well, let's take a look at things. Day 1, he spends a toonie. So he gets 1 25-cent and 3 cents back. Or sorry, 3 1-cents back. Am I going to have to expand this into more of a chart? Yeah. Let's start with a little bit of a chart. We'll keep a tally of what sort of change he has. So we'll do day. How many 20 cents? How many 25 cent? We'll do 1 cent. If we have to add other columns for 5 and 10, we will, but I don't know yet whether or not we will. So after day 1, on day 0, he has this number, 365. He starts with 365 200 cent coins. After day 1, he has to spend one of them. Those are the only things he's got. He gets 1 of these back and 3 of these back. We've already marked that. On day 2, he doesn't have enough in the other change to make 172, so he's still going to have to spend 1 of these toonies. So he gets 1 more quarter, so that's 2, and he gets 3 more cents, so that's 6. Same thing happens on day 3. He still has to spend the 200 cent. So we get 3 and 9. Same with day 4. So now in other change he has $1.12. He has 1.12. So it might be that he can only have 5 or 6 of these coins. So day 5, he still has to spend 1 of the toonies. He can't use $1.12 to make 175. Now he's got 140. And now he's got 150 plus 18. So he has 168 cents in other change, so he will have to use another 200 cent coin. That gives him 7 and 21, and then on this day, 8. He will still have. He won't spend a toonie, and he will spend these guys, and he will get 24 cents. And these guys will go down to 0. Okay. So following these rules, at the end of day 7, Ian will have 7 25-cent coins. We know he can't have more than 7, and we have found a way that he gets exactly 7. So that concludes B part for us. What is the maximum number of 25-cent coins? Well, we figured that out. It could be 7, and it can't be anything more. And it'll have to be 7 at the end of a day. He'll never get 8. He'll never start the day with 7 and then keep that 7 throughout the day. He'll spend that, some of that at least, making the $1.72. Okay. Now, C part. How many of each type of coin does Ian have in his coin jar after 277 days? Okay. That's interesting. So doing 277 days. So we're not doing the full 365 days. That's fine. I am guessing just based on the way we had to answer B. To answer B, we actually had to figure out a couple days and actually show that he could do 7 25-cent coins. And the way these things are set up, A and B help you solve C. So C, I'm guessing if I continue that table, and you would have had to have done a table in B part. So if I continue that table, maybe I'll find a pattern that I can do. Then again, when we did question number 3D, I couldn't find a pattern. So if there might be a pattern, but maybe it's a pattern I'll miss. What if there's not a pattern? I don't want to write a really lengthy table, so let's see if there's maybe another way we can do this. So anytime he spends a toonie, he gets 28 cents back in change. And we know that's a quarter and 3 1 cents. So 1 25-cent and 3 1 cents. Is there ever sort of a break-even point where he spends all his other change and he's just left with toonies again? Because we start with only toonies. And then we get some 25 cents and some 1 cent, and maybe somehow eventually we'll get some 5 and 10s, but I don't think so. But we can keep track of how much non-toonie change he has. He gets 28 cents each day. So 28 cents, when does that ever become a multiple of 200? Okay. Yeah. Because then once he's got a multiple of 200 in terms of change, he would just keep using that. Or he would have used it all along. And we would sort of eliminate everything. Thinking. Right? I mean, there's clearly patterns going on. We're back to 0 for the 25 cents. And then we'll go up to 1 and 2 and 3 maybe. And these 1 cents seem to be increasing by 3 each time. So eventually those will become greater than a 25-cent piece, and everything will sort of roll over. And we'll be back to zeros. But are we ever back to 0 again? $277 is such an odd number, and I do mean weird number, not non-divisible, not non-even, that we'll probably have to do at least some bit of a table at some point, just to keep track of everything. But let's try something a little more mathy, because D part in question 3 was a lot of bookkeeping. I don't want this question to turn into a lot of bookkeeping just to find a pattern. So let's try something a little more interesting. So do we ever only have 200-cent coins again? We start off that way, but do we ever get that again? I don't know why I keep accidentally writing change with an I in it today. This is exactly why I became a mathematician and not a speller. So this happens if the amount of change in So let's think about this. If somehow he had no, now not changing the jar being a multiple of 200. So if all the other change, the non 200 cent change coins, okay, if it's a multiple of 172 cents, then you can think about it this way. Suppose he doesn't follow the rules that he has to do the minimum amount of change, and so he just accumulates his other change. All he keeps spending $2 toonies, 200 cent coins, and then eventually he gets a multiple of 172 in his other change. He can just spend that multiple of 172 in other change for the next however many days. Then he'll be rid of his other change and he'll only have 200 cents left. And then you have to realize that if it ever reaches the point where the amount of change he has accumulated is 172 cents, then this will have happened. Okay, so let's stop and think. Is there a good way to write that? Because the Friar and the Galois and the Hypatia, these are written contests. The written explanation is key. So, I think I want to rephrase this last paragraph, actually. One also needs to remember this is a 9th grade contest, so you don't have to be the most in-depth. You have to give a general reasoning. You don't have to do, some lengthy geometry proof or whatever, just to get your point across for 1 mark. There I go, writing an I in there again. Still don't think I'm saying this the right way to get my point across, and that's very key. And if I were writing this on an actual contest, I might say, well, this is a really hard concept to get across. Maybe I should just look for a pattern on the table. But then again, I have an idea of how to write this answer. Even if I give a bit of a sloppy explanation, it might save more time than trying to find a pattern that might reveal itself only after, 20 steps of the table. All right, here's what we're going to do. Suppose Suppose after X days we only have 200-cent coins in the jar. You know what? Because I like using the multiplication sign, we'll say it happened after D days. And the amount spent on tea, I keep thinking it's coffee. So that's how much has been spent on tea. Okay. Now, where are we going with this? We're going to introduce a new variable, t be the number of those d. So t of those d days, Ian only used a 200-cent coin. Because remember, by a previous remark, he can, at worst, he'll just spend a 200-cent coin. Any other day, he will just use a bunch of his change. Right? If he doesn't use a 200-cent coin, that means he has a better approximation of the $1.72 he has to pay. And that'll come from other lesser coins, be it 1 cent, 5 cents, 10 cents, or 25 cents, any combination of those. Although the way our chart looked, we're only going to have 1 cent and 25 cents. But who knows, maybe a 5 cent or a 10 cent would creep in there somehow. We don't know. We're not making assumptions as to what that table's going to look like. But d minus t other days, he uses his more exact change. Okay. So anytime he spends a 200-cent coin, he gains 28 cents in other coins. Okay, so the other d minus t days, he just spends his other coins, which he has accumulated in 28-cent increments. right? The other days, those D minus T days where he's not spending a 200-cent coin, he's spending from his other coins. His amount of other coins might vary, but in total, their total goes down by 172 cents. So I'm just trying to narrow in on an equation I might be able to set up. Alright, I think I've got it here. He can only get new other coins, like he can only add to his total of other coins by spending a $2 or a 200-cent coin, and that gives him 28 cents. Any of the other days, he just decreases his total amount of other coins. So then his total amount of other coins, which is 28 cents times T, because that's where he gets all the other coins, must be equal to the amount of other coins he actually spends. And since he spends them all, that must be a multiple of 172 cents. So we can set up this equation right here. And that tells us that 208T plus 172T is going to be 172D. Well, that's 200T equals 172D. And now we just need to sort of solve for T and D. So this expression 200T, which we know is the same as 172D, this is a multiple of 200 and of 172. So we know 200 is going to be, that's 2 to the power of 3 times 5 to the power of 2. 172 is 2 to the power of 2 times 43. Okay, so 2 to the 3 times 5 squared times 43. And that 2 squared is covered by the 2 to the 3. This is the easiest way to find a lowest common multiple. You use prime factorization. And we get 8600. Yeah. So just at its most basic, we would have TD be 4350. So that's the least it can be. We could also have 86,100, and we could have 129, 150, things like that. 200 and that's 129 plus 43 again. So 215 and 250. And that means that every 50 days, Let's just interpret what these numbers mean. Remember, D was the length of time to get only 2 knees in the jar again. And in those 50 days, we have used 43 toonies. 200-cent coins, just to be consistent. All right. So every 50 days, we've used only 200-cent coins, and of those, we only have 200-cent coins left in the jar. And during those 50 days, there are 53 days we use the 200-cent coins, and 7 days that we use up the other change in the jar. And eventually, that other change gets depleted, and then the cycle repeats. So after 250 days of this, because remember, what did the question ask us for? We asked for how many coins of each type, or how many of each type of coin does Ian have in his coin jar after 277 days. So every 50 days is what we're looking at for only having toonies in the jar. So after 250 days, we only have toonies in the jar. So we can start our process over again. And how many toonies has he spent at this point? How many toonies has he gotten rid of? Well, he started with 365. He used 215 during that time. So it's a simple calculation. We have 150 200-cent coins left. So now, let's complete a bit of the table. I don't think there's a faster way to do this. Okay, so day, 200 cents, 25 cents, 1 cent, because I know these ones are going to be involved. I don't know whether or not 5 cents or 10 cents will come into this. They may or may not, who knows. So, the end of day 250, we have 150, 0, 0. 251, 252, 253, 254, 255, 256, 257. Only 20 more to go at that point. So we're still going to have to fill out a fair bit of a table. I don't know whether or not this method would be faster, or it is faster than trying to recognize a pattern from looking at the table or not. But this is the one we've gone with. $270, $271, $272, $273, $274, $275, $276, and finally $277. Okay. Looking at it, there might be, if there was some way to show that you only got quarters and 1 cent pieces, there might be another pattern that we could show that every, 10 days you get the same number of quarters, or I think at the start we showed every 7 days the quarters resets or something like that. So that might be a pattern you could see as well. So we get the same little bit of the pattern that we already saw. 146, so we have 1, 2, 3, 4, 3, 6, 9, 12. We already figured out part of this chart already in B part. and 143, 7, and 21, and then we get 24. This goes down to 0. So we've spent those, and we still have 143 left here. Okay. Now, the other change, we don't have enough to make 172. So we use one of these guys again, and we get 27 here. 141, 230, 140, and that gives us 333, 139, probably have to use 138, so that's 4 and 36, 5 and 39. Now 5 and 39, is that enough? 5 times 25, 125 plus 39. So we're not there yet. That's 164. So we'll have to use another one of these. So 137, 6, and 42. But now that is enough. 6 times 25, that's plus 42. $192. So we don't need to use a toonie this day. We can use our 6 quarters, so that's 0. And we can use 20 of these cents, so it comes down to 22. Okay? But now we don't have enough, we got to use a toonie again. And we'll still keep going up by 5s, or sorry, by 3s. Three, 4, so that's 31, that's 34, getting close again, 32, 5 and 37. Well, 5 and 39 wasn't enough, so we're going to have to go one more. 6 and 40, and so we'll go back down to 0, and we subtract off 20 here, so it's down to 20. And then we resume work, so that's 130. That'll be 129. $128. That'll be 1, 2, 3, 4, 5, and that'll get us to the day that we want. So that'll be 23, 26. 29, 32, and 35. Okay. Wait a minute. I went down 20 here, but that's because... no, I should have gone down 22 here. So it just struck me that I had 190 here. It ended in a 0, and then I ended in a 0 again. But if I subtracted off 172, I should have an 8 or something in there. So the numbers struck me as odd, so I may have to redo this whole thing, and I don't want to. I'm down to 120. I'm not down by 20, I'm down to 120. Or down to 20. Let's see if just the pennies will work out. 23, 26, 29, 32, 35, and that still wasn't enough, so we did need to go to 6. 38. So 172 minus 150 for the 6.25 cents. And then we need to make 22 cents here. So we have 16 of these guys. 19, 22, 25, 28, 31. Now, was that the only place I made that mistake, or do I have to go back further? That's fine. That's fine. That's fine. All these are 3s. I think that should be the right answer. Now let's see what sort of pattern we might have had if we'd done the table, because we have part of a table here. So after 7 days, the quarters reset, but then it's 6 days till they reset again, and then 6 days till they get reset again. And it doesn't look like the 1 cents reset for a very long time. They likely only reset every 50. Yeah. Okay. So at the end of day 277, Ian has 126 200-cent coins, 5 25-cent coins, and 31 1-cent coins. So we didn't use 5 cents or 10 cents anywhere in there. Interesting. All right. So we had to do a bit of a combination of chart work, which is mindless bookkeeping, which I'm usually against in questions. But we also used some lowest common multiples and a bit of intuition, asking, does the number of coins in the jar ever reset? Is there a pattern of this particular type? But I mean, if you're the sort of person who wanted to write out more of the chart and find a pattern that way, by all means, absolutely go for it. So there's at least 2 different ways to do it. We used a bit of math and some chart work, and you could have used some chart work to find the pattern, and I guess maybe prove that the pattern works and figure all that out. But either way, I like when there are 2 strategies for a question. I think that's a good way to do things if you can have 2 or 3 strategies for a really hard question like this. That way people aren't left out in the cold. If you just want to mindlessly write out the chart until you find a pattern, you can do that. Or if you think you have an idea for a pattern or where a pattern might be hiding, great. So I think that's an excellent question for the end of the 2011 Friar. Hopefully you enjoyed it. Hopefully you enjoyed the whole contest or all my Friar videos. And if you have, throw a like on the video or feel free to subscribe for more. We'll be going after the 2012 Friar next. So hopefully you guys will join me for that video. Thank you so much for watching.